Section 6.3 is going to go over what's called factoring trinomials in the not so nice case. If you were to look at our handout, keep track of things. This was section 6.2 right here, factoring trinomials in the what I call nice case. By nice case, I meant something like this right here, because the coefficient of your x squared term was 1. What if your coefficient of your x squared term is something other than 1? Well, that's going to be the not so nice case, this right here. It's the not so nice case because there's more work involved in finding these. Now, I'll be very honest with you. When I was a student taking this kind of stuff, I was terrible at factoring these things. I hated it. Just couldn't figure it out. But no one ever taught me the little trick that I'm going to teach you. First things first, though, let's do this. Let's do 5x plus 3 times, say, 4x plus 7. Let's multiply those two together. I want to dispel a notion, a tendency that people often do. 20x squared, 35x, it's all right, plus, yep, there you go. Now when I add these together, it's 20x squared plus 47x plus 21. Yay. Now, our goal here in this section is going to be the same as it was in the last section. We're going to start out with something like this, and we're going to want to factor it. Well, what I want to prove to you is this. We can't just do what we did in the last section. It doesn't work. Based on what we did in the last section, we want to find two numbers that multiply to 21 and add to 47. Are there any two numbers like that multiply to 21 and add to 47? No. But there's how to factor it. We know it factors. We know what it is. So how are we going to reverse engineer things to get back here? If we can't multiply two numbers to get 21 and add them to get 47. Well, good question. We're going to do something called the AC method. So AC method is kind of outlined for us on our handout. So it's for multiplying, or it's for factoring things in the not so nice case. When you have a number that's something other than 1 in front of the x squared term. Don't do it if you have just an x squared term. Do it if you have like a 2x squared or a 3x squared or something other than just a 1. Also, don't do it if you can factor out a GCF. Factor that out first. We'll start with problem number 22. 2b squared plus 7b plus 3. Now the first step in this method is to multiply the outside terms. Multiply the a times the c. In this case, that's 2 times 3, which gives me a 6. The second part of this is to find two numbers that multiply to 6 and add to the middle number. So find two numbers that multiply to 6 and add to 7. Exactly. So let me just always do this to kind of color coordinate things. That's where the 6 is coming from. This is where the 7 is coming from. Two numbers that multiply to 6 and add to 7. Well, 2 and 3 multiply to 6, but they don't add to 7, right? So you have to choose another pair of numbers that multiply to 6. 6 and 1. 1 time. No, the 6 comes from right here. It's the first step, right? The first step was to multiply the outside two numbers. So this and this. So start by multiplying those two together and you get a 6. And so now we're going to want to take and find two numbers that multiply to 6 and add to 7. So there'd be 1 and 6. Now what's coming up is the hard part. If you can get past this, then we should be golden. 2b squared plus 7b plus 3. We're going to use these two numbers to split up this middle term here. How are we going to do that? Well, I'm going to write 7b as 1b plus 6b. Can I do that? Well, 1 plus 6 does give me 7. Why did I choose those numbers? Those are the numbers that I had right here. There's your 1 and 6. And it might just look like, oh my God, you just made it even worse. Not true. Those were really, really careful choices. We're going to finish this by grouping. I can factor out a b from this first pair. It leaves behind 2b plus 1. What can I factor out from the second pair? 3. George, if you factor out a b from the second pair, 2b plus 1. Good. Can I go any further? Yeah. Factor out the 2b plus 1. So 2b plus 1 times b plus 3. Yay. Nice. And faster than a Detroit Lions comeback, we got the factorization. Good deal. You could check it by foiling. I know you have complete trust in me, so we won't do that, but you could. Let's try a different one. Problem number 26. Was there anything on 22 that you want me to review before we move on to 26? Yes, sir.
I did not understand what you did last after you took 3 out of 2b plus 1. What happened next?
Well, these two terms are the same. So I factored it out. This is just like the last step in factor by grouping. So I had a b here, that became here, and I had a 3 here, and it's here. So I factored that out, and I left behind the b plus 3. Okay? You're welcome. Thanks for the question. Okay. So let's take a look at problem number 26. Ooh, there's a Java update that's ready for us. 5n squared plus 12n plus 7. So let's go through these steps again. First one is to multiply the outside numbers. So it's going to be a 5 times 7 gives you 35. You have to do this in problems like this. If that number was if this was just an n squared, I wouldn't be going through this. But because there's a number out in front, a 5n squared, then I am going to do this step. So 5 times 7 is 35. The next step is to find, I feel bad using the hashtag. When I grew up, this meant number. So find two numbers that multiply to 35. And that 35 is coming from right here. There's your 35. Find two numbers that multiply to 35 and add to what?
12.
Add to 12. And add to 12. And the 12 comes from right there. Now, Sam's got it. Does anyone else have it? What are those two numbers? 5 and 7. Now this is kind of a strange coincidence. That these two numbers are the same as these two numbers. That usually doesn't happen. But that's okay. Happens in this case, that's fine. So I've got 5n squared plus 12n plus 7. I'm going to split that up. Yeah, no, you're right. 5 plus 5n. So those two terms add up to 12 and they multiply to 35. So there you go. 5n plus 7n gives you 12n. In rewriting this line like this line, we've got another way to factor it, and that is with these four terms we can factor by grouping. So I'll take out a 5n from the first pair, 5n times n plus 1, plus 7 times n plus 1. Done. What's the last step? Don, you're a ventriloquist. That sounded like Tomer. I was impressed. All right. N plus 1 times 5n plus 7. Thanks. Okay. Let me do another one, and I maybe give you one to try. But the next one I do want to do is problem number 74. So we're taking a big jump up. And of course, I'm not on the right page. There we go. No, it's not 74. Oh, that's the wrong section. There. Here we are. 74. 8m squared plus 5m minus 10. Again, because this number is different than 1, we're going to start out with multiplying the outside two numbers. 8 times negative 10 is negative 80. So that's the first step. Second step is to find two numbers that multiply to negative 80. What do these two numbers have to add to, Sydney? Have to add to 5. Good. Good. So add to 5 and multiply to negative 80. So you start scratching your head a little bit. And then you decide, you know what, let's just kind of be methodical about it and write ourselves a little t-table. They have to multiply to negative 80. I'm not going to worry about the negative part just right yet. So 1 and 80, that's a possibility. 2 and 40. 3 doesn't go into 80. But 4 goes into 80 20 times. 5 goes in there 16 times. 6 doesn't work. 7 doesn't work. How about 8? 8 and 10. And because if we go any farther, we're going to start to repeat ourselves, that's as far as we've got to go. Okay with that? Now these numbers are going to multiply to positive 80. I need something that multiplies to negative 80. So I'm going to make the larger one positive and the smaller one negative. These now multiply to negative 80. And if you have them reversed, it's not a big deal. What do they add to? These add up to 79, 38, 16, 11, and 2. Did any of them add up to 5? No. That means it's prime. Yay. If you can't find two numbers that multiply to this and add to that middle number, it's prime. And that's what I really like about this method. Because when I was taught how to do these things, it was guess and check. We would sit there and say, okay, well, the first two numbers have to multiply to an 8m. So I could use maybe a 4m and a 2m. And the next two have to multiply to negative 10. So like a gazillion combinations you could put. Negative 1 and positive 10, positive 1 and negative 10, 2 and 5, and there combination. And you'd have to sit there and check them all. And when it was all done, then you're like, oh, well, I could also use 8 and 1. And then you have to check all those possibilities again. Oh, I hated it. Just hated it. This is nice. We know it's prime. That's it. Done. End of story. Now, if you're good at guess and check, hey, that's fine. I am not going to make you do this method. But I like the AC method. I think it's pretty cool. How many have seen this one before? This kind of technique before? Just one? Two? All right. To me, it really beats the guess and check method. Hands down. And this is most of the reason why. I was never sure if it was really prime or if I just wasn't clever enough to figure out how to factor that. Let's do one last one, and we'll call it a day on section 6.3. What I'll do for my afternoon class is, or for the next class coming in, is I'll do a different set of problems. That way, if you want to watch the videos, they'll have two different videos that you can watch for this section. Because I know it's tough. It's challenging, but it's worth the work. Get it done, and get good at factoring these things, because you'll see them often enough that you want to conquer this. So let's see. The last one I'll try will be problem number 38. So 5y squared minus 18y minus 8. Big E. Where should I start? Good. 5 times negative 8 is negative 40. All right, good. Find two numbers. Yeah, numbers that do what? What are the properties I want from these two numbers? Perfect. Multiply to negative 40 and add to negative 18. All right, so multiply to negative 40 and add to negative 18. So here's the negative 18. That's where that's coming from. And the negative 40 is right here. Now, if you can't see those things right away, that's okay. Make yourself a little table like we did in the last one. So here's negative 40, 1 and 40, 2 and 20, 3 doesn't work, 4 and 16, no, not 4 and 16, 4 and 10, 5 and 8, let's see, the larger of these is going to have to be negative. So I'll make that negative. When you add these up, here I get negative 39, here I get negative 18. I can stop, right? These are the two numbers that I need. So the two numbers are positive 2 and negative 20. (5y squared minus 18y minus 8. Split those numbers up. Now it's up to you what order you put them in. You could put in the plus 2 and the minus 20, or the minus 20 and the plus 2. You'll get the same factorization either way. I like pairing up the 20 and the 5. Minus 20y plus 2y, like that. Let's finish it up. A little more factor by grouping work here. What's in common to these first two? 5y. Leaves behind a y minus 4. And from the second pair, a 2, which also leaves behind y minus 4. And last but not least, y minus 4 times 5y plus 2. Yay. For homework, let's try 21 through 65. That's section 6.3, 21 through 65. See ya!